Hi everybody. In today's episode, I want to crack a very very simple crackme, but with a twist. I want to automate the cracking of a crackme, because in a recent video called How to Crack Any Software, some of you mentioned that I can use the strings utility to reveal strings that are embedded in a file. So that sounds incredibly useful. And it was not just a single comment, it was multiple such comments mentioning the strings utility. So we will try cracking something with that strings utility today, and we will learn some interesting new concepts. So what I've done is I've downloaded a crackme, and it's this one. It's called Easy Crackme, and the description says no, it's not hashed. So that effectively means that the password is embedded in plain text here, and it's difficulty 1.1 out of 6, I think. So it's very, very simple. I acknowledge that it's not, this is not, well, how should I put it? We're not doing CIA level hacking today. We're just exploring some interesting concepts in programming and software engineering today. All right. So I have this crackme, and normally what my approach would be I would execute the crackme, enter a password, for example, hello, and get an access denied. Then I would maybe try another one just for fun, knowing that the likelihood that this is the correct one is infinitely small. So how should we go about it? In the last couple episodes, what I did was I searched for decompiler online, decompiler explorer. This one was quite useful, and I decompiled the code into pseudo C code, which is already very useful. And then at some point you can get you can reverse engineer the code and see the embedded strings if you are lucky. It's not even always the case. We also had an episode where it was not the case, even though the string was embedded in the binary. All right, so somewhere in this crackme, the string is embedded. Now let's have a look using the object dump utility, which is, by the way, for everyone who does not know, object dump displays information from object files. Yeah, and an executable is a so-called object file. It's a file that contains stuff. All right, so let's object dump the crackme, and we have to specify a flag, either the simple -s flag to display the sections in the crackme, because the crackme is in a so-called ELF format, which is the compiled format for executables on Unix systems, as far as I know. So we can just dump that file to the terminal, or even pipe that into less, so we can explore dynamically here. And you can see all the memory locations here. Well, in the leftmost column you can see the memory locations, and in the right, in the columns to the right of the memory location, you can see the values in hexadecimal format, or in the rightmost column, you can see the values translated to ASCII characters. So if there is a string embedded in this file, then we should be able to see it by scrolling through it, because it should pop up somewhere here in this ASCII file column. Yeah. So the password, if it's in plain text embedded in the object file, should be there. Now, if we just scroll through that, there's not so much inside. At least there's nothing that we can immediately spot as an obvious password. There's nothing that says hello123 or I am the password exclamation mark or serial key dash 2000 or something like that. There's no obvious password here. So how do we now find the password? As everybody in the comments suggested, we can use the strings utility. Let's have a look at the man page. Strings. We can use the strings utility to print the sequences of printable characters in files. So whatever file you have, let's just create a text file. Hello, I am Daniel. This is my text file. This is a pure text file, and if we do strings text, then this dumps all the strings from the text file to the console. But the good thing, the interesting thing is this will not just dump the strings from a pure text file, this will also dump strings found in any file. So let's open the man page again. Strings. Let's open the man page again and have a look at the description quickly before I try it. So for each file given, GNU strings prints, the GNU strings utility prints the printable character sequences that are at least 4 characters long, or the number given with the options below, and are followed by an unprintable character. So usually a string, especially a password, is longer than 4 characters. And at some point it needs to be terminated by a null character, which is just a byte filled with zeros. And that's an unprintable character. So technically any password embedded as clear text in the ELF object file should be printable with the strings utility. Ironically, I find it interesting that, to not bloat up the output from the strings utility, it outputs only character sequences that are at least 4 characters long, but so this would by default not spot any passwords that are smaller than 4 characters. Which I find interesting, but in a real case it will never be smaller than 4 characters. But also in real life, nobody would embed passwords in clear text. So we are just dealing with imaginary fun here in this episode. Anyways, it's just an awesome concept to have. I think it's awesome to have the strings utility available to us. Let's have a look at what happens if I call the strings utility on the zip file, which is the file that I downloaded from the crackme.1 page from this website, which wraps the crackme file. So just to try out the strings utility, let's check out this. And as you can see, it prints out all the strings from the zip file itself. We can also pipe it into less. And as you can see, it contains some real strings, such as crackme ut, wherever that comes from, I have no idea. And then probably some random data that appears like strings, but is probably meaningless. Yeah. And that is because the zip file is encrypted. So similarly, if we call strings on the crackme now, that's the output. And as you can see, we have quite a bunch of useful or real looking strings. They are real string data, such as this path up here referencing this library, some method calls here, then the string comparison, printf, glibc references, the password prompt itself, then the error message, access granted, access denied, some suspicious looking string that could be the password. This looks like a password in my opinion. And then some other stuff. But nothing here is in my opinion, this one looks like this one has the best chance of being the password. So let's just try it. So I'm copying this string here. Let's copy it and let's call the crackme and let's enter the password and see. And it says access denied. And now that is quite surprising because what else in this crackme could be the password? Those are all the strings that are used in the crackme, but nothing stands out as an obvious password. So what is the password? And instead of trying all the strings manually now, we can just automate the cracking. Well, we can automate trying out passwords which are returned by the strings utility. And just like this have a clever way to brute force the password, because something in there must be the password, assuming that the password is embedded in as clear text. So what can we do now? Let's write a small bash script that takes as input the crackme file and returns as output the password. So let's write a bash script, crack.sh. And maybe I should even create a project repository, a directory for it. So let's go into projects, make directory, crackme. No. Bash crack. And by the way, those are all the projects that we did on this channel so far. There's quite a bunch of them, dozens. So if you are interested in getting the code, you can get it if you become a supporter on Patreon. We have a private GitHub repository where all that code is version controlled. Anyways, so let's go into the bash crack directory and copy the crackme over here. And I think that's already it. So we can create this small crack.sh bash script, and it's a bash script shebang bin bash. And what we want to do now is, we want to read as input a file name. And we can just shortcut that with fn. And aside from that, we want to call the strings utility with that file name. Sounds good, right? So let's go into the projects directory down here. Let's go into bash crack and execute the crack.sh file. Crack.sh, and it does nothing because it expects an argument, and the argument is now crackme. And as you can see, now it outputs all the strings to the console because we just call the strings utility up here. Now, what do we do with it? We want to loop over all the strings in this output and try all those strings as passwords. So what we do is we do a for password in this function call do done. Do something and then done. So what do? We want to try out the password. So how can we try the password? Let's just print trying password without actually doing something, just to confirm that the syntax is correct. And it's not correct because obviously I am instantiating a variable here, so I have to remove the $, because the $, is only to be used when we want to access the value of a variable. But here we want to assign the value of that variable. And we can also add the printing of the password into the echo statement. And maybe just to be safe, we should put that in curly braces, just to be safe from whatever intricacies the bash parser has. All right. And as you can see, now we're trying out passwords, or at least we're printing out trying password, concatenated with the password that is tried. So we're trying password, and what do we want to do next? We want to actually try the password. So how do we try the password? How can we have the bash script try the password interactively? What we do here in the crackme is we enter the password manually. For example, 123456, and we get an access denied. However, we can't interactively do anything in bash, so we have to automate it. We have to pipe the data into the crackme. And here we have to just trust and hope that the crackme accepts standard input. So let's try that. Hello. And let's pipe it into the crackme like this. And it's tried the password and we get an access denied. So it checks, the crackme seems to really check standard input. Well, obviously it checks standard input because it's accepting standard input here. But there's no further complexity in the code, so it's just reading standard input. It doesn't matter whether it's interactively typed here or piped into it. Yeah, it's not limited in any way. So by piping we can just pipe the password here into the crackme, and by piping the password into the crackme, we get a result. So let's try piping the password. So echo and then password, value of password. And let's pipe that into crackme. And we don't pipe it into crackme because we want to pipe it into the file name to be able to work with multiple crackmes. Now, let's see what the script does now. Let's call it crack.sh, crackme. And as you can see, something is happening, but it doesn't look too good. Trying password, global offset table, crack.sh, line 7, crackme, command not found. And that is because, okay, we are providing the name of the crackme like this. So what is executed in bash is something like this, crackme, crackme, and bash is looking for some binary file, some executable defined in the path variable, which is not found. To execute the crackme file in the current directory, we have to prepend it with the // which indicates that this file is to be found in the current directory. So we have to echo something into the crackme like this. And that's why we have to prefix it with the // here. Now, obviously, this will only work if we are also, if the crackme that we specify and our program to be executed are both in the same directory, I think. But never mind. So crack.sh, crackme. And as you can see now, we have a couple of trying out password prompts here and a response, access denied. So let's have a look at strings crackme to see what the other message is. Because there's the access denied message, and the other message for success is access granted. So we could check if the output from this contains the word granted, then we have successfully found the password. Or alternatively, maybe this is a bit more flexible, If the output does not contain the string access denied, well, if it does not contain the string denied, then we know it's, if we know it's not, it does not contain the string denied, then it's successful. Yeah, we have to select one of those logic variants. So what do? We create a variable. Let's try that here. So we are currently echoing a password into the crackme, and let's say we want to store the response. So we could create a variable response, and the response is whatever the result from this execution, the response is whatever the result from this execution is. So response is equal to execution of the following bash commands, and then this one. So what is happening here? I have assigned a variable called reps1. All right, so let's echo reps1 to the console, and it's empty. Why is it empty? Huh? Did I mess anything up? crackme is still there. Enter password, blah, blah, blah. Access denied. If we now create a variable response and put into it the value echo password piped into the crackme, then the value should be stored in the response variable response. Oh, and it is. Okay, so this is how we can assign a variable in bash and store some value in it from an execution. So what we can do now is we can do the same thing in the script. Which is done now. And now we want to check for the denied string. So we currently know that all the failed password attempts contain the string denied. So what we do now is, if the response does not contain anything, any string, or well, that ends with denied, so anything ending with denied, which would apply to this whole string, which would match this whole string. So if the response is not something denied, then we know we have the password. Then we can echo password found, and the password is and we can just print it from the password variable. Let's close that if statement with a fee. And also close the echo, of course, with a closing quote. And now we can also remove the echo trying password message, because it's only going to bloat our output. So I want to only print the password that is found. So I think we are ready to try that out, and let's see what happens now. So in summary, we have created this crack.sh script, and we can give it the crackme, and let's see how it deals with this crackme. Let's see. Can we find the password? No, we can't, because now everything is assumed to be the password. Why? The response, and I know why. We have to, of course, check the value of the response, not the string response itself. So currently it was, or before that fix, it was checking if the string response contains the string something denied. But of course, we have to dereference that variable and get the value of the response variable. All right, so let's save that and check one more time. And as you can see, a password was found among all the strings, and it's .rdata. So the creator of the crackme was trying to fool us by making the password sound as if it was some object dump, as some section from the crackme, because all those sections here are called .data, .comment, .text. Yeah, so they were just trying to mislead us, believing that there's a section .rdata. And as you can see, the string is even hidden here in plain sight. We just didn't know that this was the password because it looks like it's part of the file structure, at least in my opinion. And even if we knew that this was the password because it's suspiciously placed before the enter password prompt, we wouldn't know how many dots are connected to it. Is that the password, or is that the password, or that, or that, or that? No idea. So we just can't really know unless we try all the strings in the crackme. Well, and that, guys, is how you automate the cracking of a very, very easy crackme. Admittedly, this will never happen in real life. Nothing worth cracking will ever store and hide a password in the plain binary, in the binary as plain text, obviously. But still, I find this is a fun little, well, exploration of how we can automate something and make our lives easier. Because now think how we can extend this. For example, there are many crackmes or, well, software with keys where we know the key is stored in the binary, but it's obfuscated somehow. Now we could technically somehow create a script that extracts all possible strings in an executable that have a certain length, or that go up to a certain length, let's say whatever, 16 characters. And then we can try to deobfuscate them automatically by applying some single character XOR or something simple. And then we can just try thousands of possible passwords that are deobfuscated. I was thinking of something like this, but this is just a small little exploration. We created an automated way to crack a very simple crackme. And this does not just apply to this crackme, this can be applied to many other crackmes from crackmes.1 as well. All you have to do is just, you have to adapt the response check, because the response in every crackme will be different. Not every crackme will print out access denied. Some crackmes will print out something like wrong password or try again. So you have to adapt the response string here. And then that's it. So we have created this small little script to find the password of that crackme automatically. Awesome. And if you enjoyed this episode, then stick around, leave a comment. What else can we explore on this channel in an upcoming video? And as always, give me suggestions in the comments, things that I can do better, because this episode also just originated from an idea, or from ideas that people in the comments gave me. All right. See you next time. Bye.